Good evening students. Today we will discuss some of the reactions which will involve the breaking of the carbon and oxygen bond in alcohols. In order to be more clear, let us see the example. As you can see here, ethanol, that is CH3, CH2OH. So this carbon has a bond with oxygen. Okay, so this is the OH that makes this compound alcohol. So the bond between this carbon and this oxygen will be broken and some of the products will be obtained. So let us first go to the reaction with hydrogen halide. So when alcohol will react with hydrogen halide, the bond between carbon and oxygen will be broken and we will get a product. Let us see what is the product in the reaction. So this is the general formula for alcohol. ROH, R is the alkyl group, plus HX, this is a hydrogen halide. X denotes the halogens. It can be hydrogen chloride, hydrogen bromide, hydrogen iodide. Okay, so when alcohol is reacting with hydrogen halides, the OH in the alcohol is replaced by the halogen in the hydrogen halide. Okay, so you will get RX plus water. This is OH and this is H, so you will get water as a byproduct. For example, ethanol, that is CH3 CH2OH plus hydrogen chloride, that is hydrochloric acid. Okay, hydrogen halide, no, so hydrogen chloride. Okay, you can say hydrochloric acid. So this alcohol is reacting with hydrogen chloride and you will get what? Alkyl halide. This is the alkyl part and this is the halogen, so you will get alkyl halide. CH3 CH2Cl. This OH is replaced by this Cl, so you will get CH3 CH2Cl, and this OH will bind together with hydrogen and this the proton will be released. Okay, the proton H positive will be released. The bond between hydrogen and chloride will also be broken and you will get H2O. So from alcohol, when alcohol will react with hydrogen halide, you will get alkyl halide plus water. Nothing but the OH is replaced here. Okay, so let us move on to the next reaction, that is dehydration. As the name is suggesting, you can say that the water molecules will be removed from the alcoholic part. Okay, from the alcoholic compound, dehydration will occur, means water will be removed from that compound. So let us see how we can aid that reaction. So for that reaction you will require H2SO4, sulfuric acid, and temperature is according to the reaction. So for the first reaction we have taken ethanol. When ethanol is heated, obviously you see, when water molecule is removed, you have to heat a substance in order to remove the water molecule. In order to remove the water vapors or the water molecule, means you are drying the substance. In order to dry or in order to dehydrate a substance, you have to heat that particular substance, right? So that is done in the presence of sulfuric acid in this case of reaction. So ethanol is treated with sulfuric acid at a temperature of 443 Kelvin and you will get ethene, CH2, CH2 plus H2O. So you see here, this is the molecule for ethanol. Now as you can see, ethene is produced. So how is it produced and from which part the water molecule is released? So it is very important here. OH is removed, you know, water, right? OH plus H. So this OH is removed from this carbon and the hydrogen is removed from this carbon. So OH, and here what is left? CH2, and here also CH2 is left. From here one hydrogen will be released and from this carbon OH will be released and you will get a water molecule as a byproduct, and the left is, what is left? CH2 double bond CH2. Clear? Since you are removing the atoms, obviously the carbon and carbon has to form the double bond in order to make up the loss. Next is another reaction. This is the primary alcohol and this is the secondary alcohol. How it becomes secondary alcohol? Because this carbon is attached with two alkyl groups, you can see, and this carbon is directly attached to the functional group. So this is the secondary alcohol. In case of tertiary alcohol, the carbon is attached with 3 alkyl groups. Here similar alkyl groups are given, but otherwise different alkyl groups are also possible here. Okay, so this is the alcohol, and here H3PO4 is added along with a temperature of 440 Kelvin. And now you see the OH is removed from this carbon, and one hydrogen, both this you see it is symmetric, right? This CH3 is similar with this CH3. There is no other any other atoms attached to it or any other alkyl group. So this CH3, this carbon is exactly similar or has the same property as this carbon, because the number of hydrogen that this carbon is attached is equal to the number of hydrogen this carbon is attached. Also it is attached with the same carbon. So you can remove the hydrogen from any one of the carbon here. So let us choose to remove the hydrogen from this carbon. What is there on the left? CH3, CH, double bond CH2. From here OH will be removed, and from this carbon one hydrogen will be removed. So you will get this. Okay, so this is a propene plus water as byproduct. Next, for the tertiary alcohol, again under the same conditions except the temperature, what is there? From here OH is removed, and from this carbon, now again all this carbon is similar in nature because this has the same number or same type of atoms attached to the respective carbon. So this and this carbon is similar. So you can remove the hydrogen from any one of them, and the OH is got from this carbon. So you will get CH3C. Let us remove the hydrogen from this carbon. So you will get CH2, then single bond CH3. So water will be obtained as byproduct. Now if we look at the trends of primary, secondary and tertiary. So tertiary alcohols have more tendency to get dehydrated than secondary or 1 degree or primary. So this is the trend, and this much only for today. Please go through the reactions. This is these are the very simple reactions, but in examination it becomes very difficult to recall amidst all very different types of reactions. Thank you.